I built a Monte Carlo machine in, you guessed it, just a few minutes. This use case is literally screaming for your attention if you're working on economic-related policies in places like the Ministry of Health, the Monetary Authority of Singapore, and in the Ministry of Trade and Industry. For those of you who don't do economics, a Monte Carlo simulation is like running thousands of what-if scenarios by randomly trying different possible values for uncertain things, then seeing what outcomes you get most often. Instead of guessing just one answer, you get a range of possibilities with probabilities, like there's a 70% chance that the project will cost between $800,000 and $1.2 million. Monte Carlo is used for stress testing banks and financial institutions. And in healthcare finance, it's a common tool used to project future healthcare costs, subsidy needs, and sizing your insurance policies. I did a class in benefit cost analysis over the autumn here at UC Berkeley, and I analyzed the socio-economic costs of running a waste-to-energy facility in Jakarta. Shout out to Elba, an Indonesian consultant who worked on this project with me. So I'm going to use our data to show you how we can create a tool that automates a Monte Carlo simulation for this particular analysis. Here's what the app looks like and how it works. I built an interface that lets you upload an Excel file that contains all your parameters and data that's required for a Monte Carlo simulation. Usually, you would have to write a rather complex program by hand and then painstakingly create all these charts to interpret the results. Now, you can create software that does all this for you in minutes. I'm going to pull out an Excel file that contains parameters and data for our analysis. For every parameter, I specify the stat distribution as well as the mean, lower bound, and upper bound. Next step, I run the analysis for 10,000 iterations, and almost immediately, I obtain the following. Number one, a histogram showing the full distribution of possible outcomes. In our Jakarta waste facility case, you see the results from a bell curve centered around a positive $578 million net benefit, with outcomes ranging from negative $240 million on the worst end to positive $1.5 billion on the best end. The visualization instantly tells you that while negative outcomes are possible, they only occur about 7% of the time, meaning there's a 93% chance this project delivers positive returns for Jakarta. Number two, a qualitative description of the results that breaks down what the numbers actually mean. The tool tells you, based on 10,000 simulations, the mean net present value is $578 million with a standard deviation of $255 million. There's a 93% probability of positive returns. Instead of staring at raw numbers, wondering what they mean, you now get plain language interpretation that you can put directly into your policy memo. As you can see, what would have taken you hours to code and fine-tune can now be performed very simply. If you're an economics policy analyst, start building your tools right now to take your policy analysis to the next level. Okay, I'm going to stop right here because I'm not here to teach you how to perform economics analysis. That should be done by economists. As usual, my intention is to show you that whatever you can imagine up here, you can probably build now. Today's use case comes from the Monetary Authority of Singapore. Shout out to my colleagues who asked me to look into building a demo for this problem. And for the rest of you guys in public service, if you've got any other use cases, please tell me. I promise you, if I know how to build it, I will feature it here on my YouTube class. In my YouTube class, I teach public servants the basics of how to build without code. It's completely free. So Singapore Public Service, if you're still not subscribed or watching my YouTube class, please give it a chance. I'll see you in the videos.